Alright, so we were just gonna do 12.1 and then 12.2 on Thursday, but Krista wanted to go fucking like skiing or some shit. So we're gonna do 12.1 and 12.2 today, and then like Thursday we'll just do for project.
Hey, I looked at this.
It doesn't, yeah, it doesn't, it's exactly how she said it. I already had it set up that way because I knew most of you would rather have fucking Thursday off to work on your projects rather than showing up for an hour each day and then working on projects. But if you work on the project here, you have all your data, I can work with you on it and you can do some good stuff. Chapter 12 and 13 is when we have 3+ samples. Groups. Now we're upping our game. Unfortunately, some of the names have similarities between them, especially when you look at StatCrunch. 12.1 is called goodness of fit. The main idea is how well does the data fit our expectations? That's the question we're answering here. So how well or how good, that's where the goodness of fit comes in. So this means like we've got more than 3 or more groups. 12.1 is on dealing with 3+ proportions. So each group has an expected proportion. For P. Proportion or probability? Proportion. They're not the same thing, but probability, they kind of line up well. They don't have to match. They don't have to be equal to each other. If you're doing something like drawing a card from a deck of cards, you expect each suit to have the same proportion. So in that case, it does, but in something like M&Ms, which we're gonna do an example with M&Ms in a second. Surprisingly enough, they do not produce M&Ms, the colors in M&Ms in the same proportions. So what we do here is data is gathered. And then we compare our observed values from the data set against the expected values. So what frequently happens? Frequently, we know the percentages. For the expected stuff. But we need the actual. Actual quantity. Not a proportion or a probability, an actual quantity. So we've done this operation before. we will do our expected value for each one. Is gonna equal n times p. Where p is different for each one. Or can be different. So oftentimes we have to actually multiply this out to find out what the expected value is. So what requirements do we have? Well, we definitely need the expected proportions. And we need the data set. Our observed set. And from our data set, we can get n, the sample size. It is usually, and oftentimes it's one sample, but it's broken up into multiple groups. Like a bag of M&Ms has red M&Ms, orange M&Ms, yellow M&Ms, green, brown, blue. So but we could do just one collection of like a 1 pound bag of M&Ms, we got a lot of data entries. But what we're doing is the different groups, so it's not necessarily 3 different samples, but 3 or more groups here. All expected values. Need to be greater than or equal to 1. For this test to work. Welcome. Same shit, different day. We're almost at the end, only a couple weeks left. Doesn't that make you sad? You didn't see it anymore. The final is on May 13th. We're doing that we're doing a little bit before final exams start. And then our actual final day is on May 20th. We're not doing the final that day, but if you wanna come in and see your grades and ask questions and stuff. You can. Last semester, they fucking came in and threw a party, it was crazy. I was surprised how many people showed up to do a fucking party. Like they were just, I think, happy fucking finals were over. So all expected values must be greater than or equal to 1, and rule number 2. No more than 20% of the groups. Should have an expected value less than 5. Less than 5. Another way of reading this last line is 80% of the groups are 5 or larger. This isn't expected, this is just the data. Have a value less than 5. Values. This is greater than 5. That's not true, it is expected values. Fucking wishy-washy on my shit. I'm doing what every fucking college student does, came back from spring break and I'm done. Don't fucking tap out with 2 or 3 weeks left of the school, don't fucking quit. You would be surprised how often spring break and Thanksgiving break just fuck students. Even the best students. You have like an A+. Go on break, take a week off, and they're just like, I got into break mode, and they stop showing up. Doesn't look like that's happening here, there's fucking more students today than normal, which is nice. But like in other classes, don't tap out the last 2 or 3 weeks, you're almost done. Summer's coming. Then you can take your big break then. Alright. Shit, Kelly's done already. Were you taking notes today, Kelly?
Yeah.
Oh, I was just lollygagging around. Alright, so what do we care about? You care about a couple things, cause you want your life to be easier. In StatCrunch. We're gonna do stats. Goodness of fit. And then it's gonna say chi-square test. Which is very, very, very fucking unfortunate because the 12.2 test is called the chi-square test for independence. I wish they didn't say chi-square here. Because it's confusing to students. It's called the goodness of fit test. And you care about H naught and HA, these are important. H naught and HA start diverging from the ones we've been doing. H naught here is observed values match expected values. HA is at least one group. Group's values. Is different. Than expected. And very rarely are they all identical, so like, this is more like in the right range of numbers. They don't need to be the exact same numbers, but they need to be like close. If the expected value is 90, 85 is probably pretty good, but fucking 60 definitely isn't. So that's why we do the test to go like, how close is close enough? That chi there. CHI is the Greek letter. It looks like a giant capital X. So chi-square is when we square it. And it's pronounced like chi, like bye. Like bye-bye. This is not a symmetrical distribution. It changes depending on the degrees of freedom. Which is n-1. You're not expected to know what the graph looks like. It just doesn't look like a bell. Or at least it looks like a skewed graph, what it looks like. I wanna say it's skewed right every time, but I'm not confident in that. So when we're doing step crunch, what we're gonna do is we're going to enter the observed values in one column. Oh my god, it's fucking train wreck here. Observed values in one column. Step one. Step two, there's two parts, two different ways this is gonna happen. If the P's are different. Enter a column of expected values. If P1 equals P2 equals P3 up to. P, let's say K, all the proportions are equal. Then we don't actually need to click, or we don't need to enter a column. What we're gonna do is we're gonna check mark the box. That says. Cells in equal proportion. Lines you actually read before I start talking then. Oh, drive me fucking nuts reading one paragraph. It's like eating a cookie one crumb at a time. It's not enjoyable. That's the best analogy I can give. You're having one crumb of a cookie, you fucking don't taste the cookie. Right? You guys ready for an example? How the fuck are you done already? Did you like learn how to write all of a sudden? What fucking changed?
Using my hand hasn't been writing notebook week, so it's. Good.
That's the excuse, you need a break.
Yeah.
It works. I don't remember how you were the first few weeks, so I can't say call bullshit.
Pretty slow.
I,
It was like catch up again.
so, M&Ms. The Mars company produces them. Mars company produces them in two facilities. In different states. Like. I wanna say one's in New Jersey, M&M produced. Actually say it on the bag will tell you which one it is. I didn't fucking help, oh well. Look it up later. But if we look at them all kind of like overall. the color breakdown is like this. It's actually different percentages at different factories, but if you do them all together. Let's make a chart for a column for color and a column for P. And I'm gonna have, since we're doing an example, I'm gonna have a column with expected values. And I'm gonna make that one kind of wide. We're gonna do some calculations here. And then I'm gonna have a column for observed values. So what are the colors? We got brown, yellow, red, blue, green, and orange. That's a standard bag. The expected proportions is brown is 13%, yellow is 14%, red is 13%, blue is 24%. Bam, blue gets a lot of love. Green is 20%, and orange is 16%. Which is surprising because their two main spokes candies are red and green. But red and green aren't the largest number of M&Ms received. Green's pretty high, but blue is largest. My wife loves the M&M characters. We have too much fucking M&M propaganda bullshit, like knickknacks around the house. Thankfully, she grew out of wanting me to buy more. So, in our example, Arturo samples 600 M&Ms. And records their colors. There were 83 brown. There were 87 yellow. There were 70 red. There were 130 blue. There were 134 green. And 96 orange. That doesn't look like a fucking vertical line. Looks like shit. Or not. I don't fucking agree with me. I can talk shit about my graph. You fucking talk shit about my graph. Alright, so. We don't have the expected values, but we can calculate them. He had 600 M&Ms. Let's assume it was not in one sitting. That's a lot of fucking M&Ms. Expected value is n times p. So what we're gonna do is we're gonna take 600 and multiply it by 0.13. And we're gonna do the 600 times the proportion for each of these. And if you do that, 600 times 0.13 is 78. This is 84. This is 78 again. 144. 120 and 96. Oftentimes with this alone, you can get a good idea of whether or not you think it's gonna work or not. Is 78 fairly close to 83? Pretty close. 84 is pretty close to 87. 78 and 70 are getting a little further apart, I don't know. 144 and 30s, quite a bit apart, but we're looking at numbers above 100. So like, maybe it's not too much. Those are 14 apart, orange is right on. I can't really tell here what's gonna happen, but if something's fucking it up, blue and green are gonna be likely the ones that are fucking it up. Cause they're a lot more different. So we're gonna, our hypothesis test is gonna be test Marge's claim that those are the proportions. And we'll do it alpha equals 0.05 level of significance. We are doing a hypothesis test, so we've got 5 steps. How many I can fit on this page, I'm gonna find out. H naught is the observed proportion of colors. Matches Mars plane. And HA is at least one is different. Step 1. What's step 2? Step 2 is our alpha, that was given. Step 3 is stat crunch stuff. So we're gonna have to go do it in stat crunch. Guys ready to go over stat crunch? Oh, Kelly said right, that's usually like the barometer. She's like, quit fucking saying my goddamn name. So was actually doing homework on her break, because she was fucking using. She's like one of the few students that actually uses Ask My Instructor. She's good, she's got a question, she just fucking asks. Alright, so we have expected data and observed data, I'm gonna label the columns. That way I don't get confused later on. This is a good idea when we're doing this. Expected and observed. And I might even do a column called colors so that I can make sure that I got everything matched up. We had brown, yellow. Red, blue, green, and orange. And we calculated expected value to be at 78, then 84, then 78. 144, 120, and 96. And the actual values that Arturo got were 83, 87, 70, 130, 134, and 96. Then we're gonna go, once you've got the columns in, you're gonna go stats, it says goodness of fit, and then chi-square. You see the observed column, I actually labeled it observed so that I could find it easy. And since since the proportions are not equal, I gotta tell it where to find it. And we're gonna do that. Expected. And we'll just do display expected value. So what we want to write down is our test stat is 4.24, and we got a p-value of 0.515. I'm gonna write those down. Yeah. What's step 4? So which one is larger? Is p-value greater than alpha or less than alpha? And what is our verdict then? What's our decision? P-val is not too low, don't reject the hoe. Do not reject H naught. Do not support HA. Step 5 is our conclusion. There is not enough evidence to support the claim that the color distribution is different than what Mars claims. At alpha equals 0.05 level of significance. This is not the same thing as saying the Mars company is right. It's very important to note that. We're just not rejecting what they say. We would just might have, Arturo might have bought a 1 pound bag that just happened to perfectly match up, but every other bag has a wildly different distribution and it could just be random chance. So we're not saying they're right, we're just saying they're not wrong. Which is different. All right? see. To do another one in chapter 12, let me go find it. Alright. I'm gonna go back over to StatCrunch and show that problem. Or, I guess it's not StatCrunch, it's Pearson. Well. So this is the 12.1 interactive, this is the one that says 13 over here. And it says a researcher wanted to determine whether pedestrian deaths were uniformly distributed over the days of the week. The accompanying data shows the days of the week for n equals 300 randomly selected deaths. Test the belief that the day of the week on which a pedestrian death happens occurs with equal frequency. And this is the values they have. So this one's gonna end up being a little bit different because if they're going to occur equally, then the proportions should be equal. Does that make sense? How many days in the week are there? So each one should have 1/7. So when we're doing our H naught, we want to go with the one that says the values are all equal, which B does, C does, and D does. And then like 3 of them say that, and then we gotta pick which one is correct here. And it's not more, they didn't say when more accidents occur or less, it's just whether or not one of them's different. So we're gonna go with D here. At least one proportion is different. So we need to figure out what this count is. They said there was 300. And P was 1/7. So N times P is 300 times 1/7. And it says it wants us to enter the 3 decimal places, which is annoying because they're all going to be equal. And I'm getting 42.857. If I can copy and paste. I can. Excellent. All right, and we're gonna do check answer. This is what we get in StatCrunch. So what we're gonna do is we're gonna load the table in StatCrunch. And we don't need to type a column for the expected value since the proportions are equal. When we do this one here, we can do stats, goodness of fit, chi-square. It looks like our observed values are in the column that says frequency. And then I'm gonna say all cells are in equal proportion, which saves me from having to type all that bullshit. If you do, it actually will tell you what the proportion or the expected value is, so. You don't even need to get out a calculator if you do it smart. This is what they wanted for our question now, they wanted the chi-square value. So they wanted the 2 decimal places. 14.21. And p-value. To 3 decimal places, just copy and paste. And it was a 4 after that, so I don't need to round. It says the problem alpha was 0.05 level of significance. So if my p-value is 0.027, what should we do? Should we reject H naught or do not reject H naught? Krista has to carry you guys. Don't let Krista carry you guys. Don't make her answer all the questions. Is 0.027 less than or greater than 0.05? It's less than. So p-val is too low, reject the hoe. So I don't know what this drop down menu is gonna ask. Oh, that's handy, it actually said that, reject hoe. The hoe is that they observed matches expected, or they're all equal in this case. Expected was that they were all equal. And so we can say there's enough evidence to support that they're not equal. Because if we reject H naught, we support HA, and HA is they're different. Right? Guess I should add that. Reject H naught, support HA. Thing with the mouse is awkward. HA is at least one is different. If one is different, they're not occurring with equal frequency. All right, let's take a 10-minute break and we'll do 12.2. All right, we're gonna continue our lecture. We're gonna do 12.2 now. As I said before, it has the unfortunate coincidence that it's also called chi-square. This is called the chi-square test for independence. So there are 3 or more groups. And now in this case, each group has multiple categories. But they all have the same categories. So each group shares multiple categories. This would look absolutely shitty if they gave you the data or the information as a sentence. This shit always comes as a table. Just because it has a table doesn't mean it's the chi-square test for independence, but it does, like, very few things use an actual table. You could show the goodness of fit as a table, but there's only one column. And chat 13.1, the ANOVA test we'll do next week, also can be written as a table, but it's also one column. Here, we're gonna have more than one column, it's gonna look like a full table. It's only one with a full thing. So we're gonna have our populations or groups across the top. Which kind of makes them the columns. You put the names on the top, they're on the top of a column. The first column needs to have the name of the categories. Names of categories. So you actually need a column that says what each row is. You notice on the goodness of fit, I wrote in the colors on the screen when we did M&M, but I never actually used that in StatCrunch. That was just put in there for me. And for you, so you can see that they matched up, but like StatCrunch requires you to have those labeled. And then so like the rows are the categories. So you have something like categories. Group 1, group 2, group 3. And we'll have like option 1, option 2, option 3. Or more, or less, but at least 2. And then in these boxes, in here, we'll put the summarized data. We'll just add up each one and put it in. If the problem is given to you as a table, it's already done for you. And it should be given to you as a table. StatCrunch. The approach we take is since it's a table, we're gonna say stats, tables. Contingency. And then with summary. So when you do that, a box pops up. It's gonna ask you to select columns. Tell it what columns have the summarized data. Not the row labels. Because the next drop down or the next box is gonna ask you where the row labels are. Choose the row label column. If you've done it like a normal person, it's gonna be your first column. I can't ever remember seeing like the labels on the right side of a fucking graph. Or a table, that just was looked back backward. Like I did with the M&Ms, I had the colors on the right. Because I didn't need them for anything, that's why I did that, it did look funny though, didn't it? And then it's also gonna ask you, display. Expected count will be our go-to. But there are some other options. other options for display, which can be more helpful depending on what you need. They'll have one that says, row or row percent, column percent, one of those. And this is pretty handy when you're doing, a conditional distributions or frequency distributions. I'm just gonna say conditional stuff. Yeah, no, actually, it also it shows you the frequency distribution, that's kind of handy. There's another one, I think it's worded something like contributions, this is a different display box. Contributions to chi-squared. And this one's kind of nice because it shows what row or column is having the biggest impact on the test statistic. Which is effectively on our hypothesis test. Here, slow down. I haven't really stopped talking and tell you it's getting my
Yeah,
ears.
it would have been nice sitting back, cause like my eyes would like look better.
They'll need to give you H on HA and the requirements. Play video games. You playing video games? Madden or fucking racing or anything like that?
I used to not.
So you used to play video games.
Yeah, sold my console like a couple years ago.
What do you do for fun? Besides drink, yeah.
I don't even like to drink.
You know, like, what do you do for fun? You don't play fucking games or fucking,
Uh, I work. I got.
it's not, but they said it's fun, not
It's like
work.
it's a hobby. I got like a law service, so I just do that every time. You just want
You don't
to
do anything for fun?
make money. Go to church on Sundays. Hang out with my girl.
God, that's- You're gonna make some wife or husband happy one day. I assume wife, you've laughed every time I said that. You guys,
I went out
she's
Saturday.
gonna be like, he's out working all the time, I can have me an extra, you know. The pool boy on the side, whatever, he's bringing home good money.
Fucking crazy.
You're at work all the time, your girlfriend or your wife is gonna start having rubbing eyes, like she really loves you. Gotta be home sometime.
I was-
Really, you don't do anything for fucking fun, watch TV or listen to music or shit?
I listen to music. I go fishing. Wash my car. Yeah,
Washing the car is not fun.
washing the car is therapeutic.
That I can go with, and so is fishing.
They're very.
See, that's your version of sitting there and doing nothing, that's what you do most of the time fishing, you just sit there and wait. You don't drink, so you're not even fucking in. Ew,
Now when I was at the bar Saturday for the first time, like I don't really go to the bars, right?
no, but like fishing, a lot of people fit, like have beers while they're fishing, because. You're literally sitting there waiting for a fish to bite.
Yeah, you can fucking talk to someone, you know people, chop it up. I don't
Which
really,
is more fun with beer.
like, I don't really like beer.
I don't like beer either, beer is disgusting.
I do like liquor,
I like, well, okay,
you know,
yeah, I'm definitely, well, when I did drink, it was liquor over beer.
yeah.
Alright, Kelly's done writing, H naught. H naught is all, where is it? Row and column variables are independent. This is a generic way of saying it. When you actually do it. For H naught, you'll discuss what like the groups are and what the categories are. You'll see. Are, not of. And then HA. There is some form of dependence. Between rows and columns. So this is where like the name chi-square test for independence comes in. You're checking independence of rows and columns, groups and categories. So that's the way to remember the H naught ties into the name of the test. Requirements are similar to goodness of fit. I don't know why I didn't say this before, I usually call that golf. You're gonna get tired of writing goodness of fit. So all categories have a frequency greater than 1. No more than 20% of the categories are less than 5. So it's kind of like we want them all to be 5 or larger. The examples I'm gonna do are from the lecture notes. Word document. I actually have all the data loaded into a stack crunch table. So if you're using your laptop here and you actually wanna work with this data at the same time. The file is saved under. Jones. Pepe. Chapter 12.2 contingency table. After this lecture, we have one section left. We're almost done learning new shit. Right? But it's gonna, we're doing it next Monday or next Tuesday, it's giving you time to. Make sure you do all the homework and know that shit before the final. Just coming soon.
Are we gonna do like a class review?
I think I have a day for that. Oh, I know I have a day for that. I'm certain of it. I don't even know what. Cause your final is not on stack crunch, it's not on Pearson, it's just gonna be a paper test.
Same question.
10 questions, all the stack crunch data will be typed in there for you. But you still need to know how to work with it, how to do the hypothesis test and stuff. So do the homework to get that practice in, cause I promise you, if you don't, you're gonna fucking fail fine. Like, I know it's annoying doing the fucking Pearson homework. Cause oftentimes they have part A, B, C, D, E, and fucking all the way up to fucking H
I put
or
them in
B. But
that. Okay.
that's a lot of shit for each one, yeah. But it's trying to make sure you understand why you're doing it, not just going through the motions. Alright, I'm gonna hop over. There's no pin in her hand, okay. Those are what the chi-square graphs look like. They're skewed right. That's goodness fit. There you go. Chi-square test for independence. So what we're gonna do, let me enlarge this for you. Make it a little bit easier to read. So. A poll asked. Based on gender, assuming two genders, not more. These are all old, they're not modern. If you could pick, or if you could only choose one, which would you pick, money, health, or love? And they divide the answers down into men and women. So the two different populations are really men and women. But they're grouped like this, and so to do, we're gonna treat these as our groups. The groups are gonna be the people that said money. The people that said health, or the people that said love. And the categories are gonna be who responded with what. Okay? We're gonna go and put this shit in StatCrunch. I already have it in there. But for those that are writing down, we'll let you write it down. I watched the finale for Wheel of Time, it was pretty good. Completely different than the book. Have you read any of those, Crystal?
What?
The Wheel of Time series?
No, I haven't read it. So now, you know, long list of people.
It's one of my favorite fantasy series.
You have class Thursday? Drop is that day?
Thursday is project day. So if your group doesn't wanna come in and work on projects, you don't have to be here. If you wanna come in and work on projects, I will be here to help.
Well, it's just the data, right?
That's what we're doing on Thursday. If you wanna,
It's just not like,
that's what's due, like the
Yeah.
collection of data.
yeah,
If you guys wanted to show up and start crunching on everything else and get it done before the last day, you can, I'll be here. If you don't, you don't have to come.
I got to drop that. didn't I?
I'm just trying to give you guys in class time to work on the project so that you don't have to meet. Cause let's face it, y'all have different work schedules and shit like that. Live in different towns, y'all don't wanna go meet each other on a fucking weekend or some shit like that. I try to arrange time in class to give you time to work on the project, yeah. But if you're happy doing shit by email, knock yourself out.
Go for it. I have a picture of the numbers.
That's okay, you're not the only one writing, so
That's the first.
other people will take notes.
It just picks on you.
Krista brings a notepad, but I don't know that I've ever seen her write anything down. She's holding the pen like she does.
I do.
Okay. I'm not saying you didn't, I'm just saying I don't know if you do. Every time I look over, you're reading. She does the whole. The court person, the stenographer, she got some fucking shorthand code for everything I say.
Okay, that's.
I'm not waiting on you,
Looking at
a
me,
couple of other people. No. You're in the same direction and I'm looking.
okay?
She's still writing, he's still writing. Alright, looks like everyone's good. They wanted to kick my ass out, you can go fuck off. Save. It. I wanna go over to StatCrunch. And say, do the StatCrunch website. And I'm gonna look up data sets. And I'll look up Jones, FA, see what comes up with that. 12.2 contingency table. Do I have the full name on that one? No, I don't. So this is what we had on the table. Money, health, love, gender, men and women. We're gonna go in and do the. Keep the stuff and then we'll go back to the paper to work it out, that full test. We're doing stats, tables, contingency with summary. The columns we're looking for are money, health, and love. Where the row labels are in gender. I'm gonna click on expected count, but then I'll show you the other ones. So if. Cause there's a different total for each group, 883 and 893. If they had the same percentages, the things in parentheses are kind of like what the expected values would be. That's how you read this. Percentages are the expected values, because you can see the 82, 446, 355, those are the numbers right there. So the ones in parentheses are what would be expected. Come down, get that chi-square table and stuff like that. I'm gonna write that down real quick, but I want to show you the other options. So this is money, health, love problem. And step 3 is StatCrunch. And I've got a chi-square value or test value of 36.8. And p-value is super duper low, it's less than 0.0001. Look at the other options real quick. If you say do it by row percent. What it's doing is telling you what percent for each row is the columns. So for men, 9.3% of men said money. 50.5% said health. 40.42 said 40.4 or 40.2% said love. Women, 5% of women wanted money. 64% of women wanted health, and only 30.6% wanted love. Which means all the fucking shit they do on TV is absolute bullshit. All the TV shows, like the romance shows, are often advertised for women, and they're not. Guys want love more than women do. Right? Weird, kind of interesting. Then if you do the column percents. It tells you by column. Of the people that said money, 64% were men and 36% were women. So it's giving you like percentages based on that, each column looking at the rows. Whatever one is the 100%, you're looking down that column or that row. So this is doing stuff in terms of money, health, and love. It's interesting that these are almost flipped. Health and love are almost flipped for men and women. And then contribution to chi-square. Shows you the impact. It looks like the health category has the biggest impact on it. I guess all of these add up to 36.9. Each of these things are parentheses, but the biggest impact was health with guys. What is this over here? Fucking heat map, I don't even fucking get the heat map. Don't fucking do, don't look at the heat map. Back to. So we had money, health, and love, and then we had guys, girls. And so we're going through our test here. H naught is. Well, these were choices. And these are genders. So gender and choice are independent. I'm not just gonna say rows and columns are independent, I'm gonna make it make sense, because when you go back and look at it for your conclusion, this is gonna help you. So it doesn't matter if you're a guy or a girl, roughly the same percentage, picks the same for each column, kind of thing. HA is there is. Gender and choice are dependent. It sure looked like it was, because a lot higher percentage of guys picked love than girls. And opposite for health. That's step one. Did they give us an alpha?
But they're fun.
They actually gave it? That's step two. Step three is there. I'm gonna move my 0.05 down here. Alright, someone's besides Krista. How do we make our decision? Is p-value less than or greater than alpha? It's less than. What is that gonna make our decision? What? Reject what? Reject the hub, yes. If p-value's too low, we reject the hub, which means we support HA. And HA was they are dependent. There is sufficient evidence. To support. Claim. That. Gender. Affects choice. Between money, health, and love. Alpha equals 0.05. Level of significance. This problem has men and women again, and the categories are like it, love it, gotta have it. Does anyone know what that's in reference to? Jesus Christ, fuck, just answers everything, whether it's a fucking pop quiz question, fucking Jeopardy,
What was the question?
like it, love it, gotta have it, where did that come from?
Sizes.
It's the sizes that both sound. So the next problem, a couple COS students, when they were doing their project, they both worked at Cold Stone Creamery. And they're like, does gender affect cup size selection? What do you like? Do you guys think it does before we even look at the data?
I mean, I really like it, my dad gets like 11, so I mean.
So you get the small one and he gets like the medium one?
Yeah.
Any theory about in general? Guys versus girls, who's gonna? Are they gonna pick equally, are girls gonna pick one over the other? Are guys gonna pick one side over the other? This is a lesson in fucking psychology. Do girls care? You've been on dates, right, Arturo? Generally, does the girl eat a lot? Like, tend to be like dainty, they don't wanna look like they're pigs.
Yeah,
Guys are like, fuck it, just give it to me, give it all to me.
they do eat their leftovers.
Yeah, and then they'll eat the girls' leftovers. So generally, in my head, I think girls are gonna pick the smaller cup sizes and the guys are gonna pick big cup sizes. And there might be like a few large for girls, so there's always the older lady that doesn't give a fuck what guys or gals think anymore. Val's like, give me the fucking big cup,
I tried.
that's right, for better value.
I'm this body shape.
I got a lot like 2 weeks ago, and then they actually were giving me, gotta have it, and I was like, this is a lot of ice cream, but I still ate it all.
They make good ice cream. Alright, let's bring that question up and we'll be done. It's always nice to think about what your outcome might be before you start going and doing it. Click undo on that real quick. I wanted to change it later on. So that's kind of like what I said. They just thought that gender and ice cream affected choice. And those are the data values if you're writing them down. Now, like it is the small one, if you don't go to Cold Stone, this is meaningless. Like it is the small one and gotta have it is the large one. This is like Starbucks where the jackasses name everything large, but in a different language. Like, no, venti is not. The tall and grande are their small and medium at Starbucks. They both are equivalent words for large. Venti is 20 in Italian, it represents the number of ounces. I'm surprised they didn't go with gigante or some fucking stupid shit. I don't speak Italian, so I don't know what another word for large is. I don't even know, is it Italian? I don't know. I think venti is Italian. I don't know where I got it from yet. I'm gonna call some at least fucking 7 or 8 years. They do make good ice cream now.
They banana pudding ones,
Really?
fucking fire,
Really?
that shit is fucking bomb.
What is it?
Banana pudding,
Not banana ice cream, but banana pudding.
no, banana ice cream, it's like ice cream pudding
Yeah.
and wafers. Fuck.
Oh, they do like that, okay. Yeah, my wife loves it when that dish is made for like a fucking Thanksgiving and shit like that, she'll grab the vanilla wafers on and the banana pudding shit. Like a couple bites of banana pudding is all I need, and then I'm like, I'm good. I'll probably go to town on chocolate pudding. But like banana. Strawberries are fucking in season now. That's fucking great. Get some sugar-free chocolate pudding, some fucking Cool Whip. Some fresh cut strawberries, oh. That's dessert tonight, we have those all in the house right now. Yeah. Trying not to have too much sugar, so we get the sugar-free shit.
Buckets.
For you, you're fucking you're slender. I don't need fucking extra sugar. I got a friend that motherfucker can put away food like nobody, like a fucking vacuum. Like a fucking shop vac, like he can just, I don't know where it fucking goes, he doesn't gain weight. Fucking pisses me off. Fucking, it's not fair, is it?
Ever had seafood boil?
What?
Ever had seafood boil?
Oh,
She'll change your life,
I'll take your word for it.
that shit will change your life, promise you.
Alright, we got the like it, love it, gotta have it here over on the table already, looks like we're done writing. We're gonna go stats, tables, contingency with summary. Row is still gender, and we're doing like it, love it, gotta have it. Really? There we go. So our chi-square for the ice cream shop, I'll write this down. Some of you already wrote down, I'm gonna write this down because I'm scanning it. Holstrom Creamery. Gender versus cup size. We have a stat crunch value of 49.7. And p value that is less than 0.0001. What was my alpha? 0.05. We'll go back over. And finish our hypothesis test. So for the chi-square test of independence, you're comparing whether or not the columns and rows are independent or dependent. So H naught is gonna be gender and cup selection are independent. And HA is gender affects cup size. Or cup selection. And even before we saw the p-value, the girls overwhelmingly wanted small cups and the guys overwhelmingly wanted large cups. There were like large eaters for women, but there were dainty eaters for guys. I don't know who the fuck they are. I had never met a guy that like ate small unless they were trying to lose weight, but if you're trying to lose weight, you ain't fucking going to Cold Stone Creamery. You know what I mean? Alpha was given to us at 0.05. That is p-value less than or greater than alpha. So what is our decision gonna be? Reject the hoe. Support HA. And HA is gender affects cup size. There is sufficient evidence. To support the claim. That gender affects. Cup size selection. At Cold Stone Creamery. At alpha equals 0.05 level of significance. Be a fucking dangerous place to work.
But now.
I know, every time I fucking give this lecture, I fucking want to. I got some weird toppings you can throw in that shit too. It's kind of neat that they mix it up right in front of you.
Yeah.
So you can choose the ice cream flavor and the fucking mixed in toppings. If you're already done writing, you're done doing shit, that's all I got for you today.
And 5, 2 days, so. Right, that is practice.
But why would I get ice cream that does that?